This is probably the longest question on this review. The Cauchy Euler equation is easy. The homogeneous part of the solution is easy. So let's just find the homogeneous part of the solution. I'm just going to use this form of the characteristic equation or auxiliary equation. So we have 1 here. So it's going to be 1r squared plus 1 minus 1 r plus 9 equal to 0. We have r squared plus 9 equal to 0. So that gives us r equal to plus or minus 3i. And when we have two complex conjugate roots, that's what the solution we're going to have. So y1 is t to the alpha. Alpha in this case is going to be 0. And we have t to 0 power, which is 1. So we really don't need to have that. So we just say cosine of beta is 3 ln of t. Y2 will be sine 3 ln of t. And then we have the solution. Which is that. Right. Now we have the solution. I'm going to erase the formula because we need all the space we're going to get, and maybe even more than that. Right. Now we continue. Next we will find the particular solution, because this one we have non-homogeneous equation. Particular solution will be in the form of variation of parameters v1, y1 plus v2, y2. v1, y1 and y2 form the homogeneous equation, and v1 and v2 to be determined, and that can be found from the equation, a system of equation y1 v1 prime, y2 v2 prime, y1 prime v1 prime, y2 prime v2 prime. This is exactly like what we did with using variation of parameters for the equation with constant coefficient. But this time we don't have the constant coefficient. So it's very important that in variation of parameters, the coefficient here has to be 1. We have t squared there, which is not 1. So what we need to do is divide by t squared on both sides. But what we have there is just negative tangent of 3 ln t divided by t squared. So that gives us the system of equation where we find v1 prime and v2 prime, and we're going to use Cramer's rule for that. So Cramer's rule is going to be on the wrong skin, or on the 2 by 2 determinants. W1, just the W, the wrong skin. Y1, Y2, Y1, Y1 prime, Y2, Y2 prime, y1 will be cosine of 3ln(t). And y derivative of that is negative sine of 3ln(t). And then derivative of 3ln(t) in sine is going to be 3 times 1 over t. So multiply 3 over t. So let's say we multiply this by 3 over t. And then we have sine of 3ln(t). Derivative of this of sine is cosine. And then we have 3 cosine of 3ln(t) over t. 2 by 2 determinant it's going to be 3 over t cosine square of 3ln(t) plus 3 over t sine square of 3ln(t). Cosine square plus sine square is 1, so we just have 3 over t. So that is W. Now the W1. W1 will be, instead of y1 and y1 prime, we'll replace the last column here into here. So we have 0, negative tangent of 3ln(t) over t squared, and then y2 prime, y2, and y2 prime. Right? 2 by 2 determinant. That gives us negative and an extra negative, so that's going to be positive tangent of 3ln(t) over t squared. Multiplied by sine of 3ln(t). Now tangent is sine over cosine, so we can write this as sine square of 3ln(t) over t square at the bottom along with cosine. Right? So tangent is sine over cosine, sine and sine on the top, cosine at the bottom, along with the t square. Right, so that is W1. W2, W2 is going to be equal to, instead of y1, y2 prime, we're going to have the right hand side, the right column here. So we'll substitute that into y2 prime. So y1 and y1 prime is still the same. Cosine 3 ln t, and then negative 3 sine of 3 ln t over 3. Over t. And then the right column, 0, negative tangent of 3 ln t over t squared. And 2 by 2 determinant give us that will be just negative tangent of 3 ln t over t squared times cosine of 3 ln t, right? Tangent is sine over cosine, where the cosine cancel out. So we just have negative sine of 3 ln t over t squared, right? So that is W1 and W2. Once we have W1 and W2, we can say V1 prime is W1 over W, and W1 is sine square 3 ln t over t square cosine of 3 ln t divided by W. W is 3 over t multiplied reciprocal t over 3, where we cancel 1 t, so we will have sine square on the top, sine square 3 ln t. The bottom is 3 t cosine of 3 ln t. That is V1 prime. We integrate to get V1, but let's just write V2 at the same step here. V2 is W2 over W. W2 is negative sine of 3 ln t and over t squared multiplies the reciprocal of, we have t over 3, and cancel out, we will have cancel out with t, we have negative sine of 3 ln t over 3t. So that is V1 prime and V2 prime. I forgot the derivative. Right. This is a long problem, so we have to continue on the next page. I have to clear this. I didn't copy all of them, but we can manage. So that will give us negative sine of 3 ln t over 3t. Right. So that gives us V1 prime and V2 prime. We will integrate to get back to V1. So we have that integration, sine square 3ln t over t cosine of 3ln t dt. I think we forgot the 3 here. Yeah. Yeah, we do have the 3. I just didn't copy on the way through. Yeah, sorry. All right. Now we just integrate. I use substitution on this one. Let u equal to 3ln of t. Derivative is 3 over t dt. So dt is t du over 3. Substitute those information into our integral. We have sine square of u over t cosine of u, and dt is 3 over t, t du over 3. Cancel a t, so we will have sine square. Now sine square is 1 minus cosine square. And we still have the 3 there. So let's just move the 3 outside. We have 1 over 3 on the outside of the integral. Sine square is 1 minus cosine square. Right. Integral of that, it's not that bad. We just say 1 over 3 still. 1 over cosine is secant, and cosine square over cosine is just cosine of u. So we will have 1 over 3. Integral of secant is ln of secant plus tangent. And integral of secant is just sine. I'm sorry, integral of cosine is sine. And then u, we've missed something again. Sorry, we still have the 3 there. So this should be 1 over 9. Sorry about that. Let's take a look at now. We still have the 3 in the derivative. So this should be 1 over 9. Sorry about that. Right. And then u is equal to 3ln of t. So I will substitute in, and we have 1 over 9 ln secant of 9 3ln t plus tangent of 3ln t minus sine of 3ln t. So that's what we have. Now we go to V2. It's much easier. We just have negative sine of 3ln(t) over 3t dt. Using the same substitution as before, we will have negative sine of u over 3t. dt is t du over 3. The 3 and 3 give us negative 1 over 9 integral of sine u du. So negative 1 over 9 sine u. Integral of sine is cosine. Sorry, negative cosine. Which give us 1 over 9 cosine of u. U is 3ln(t). And so we have that. So that is V2. Once we have that, we can write the solution, the particular solution. I need all the space I can get. Alright, now we go back to particular solution. Y equal to V1 y1 plus V2 y2. That is our particular solution, which equal to V1 is that 1 over 9 ln of secant 3ln(t) plus tangent of 3ln(t) minus sine of 3ln(t). But not only the V1, we still need to multiply by y1, which will be the cosine of 3ln(t). Hate when that happened. Just erase everything and try to write smaller. Right, V1, once again, 1 over 9 ln secant of 3ln(t) plus tangent of 3ln(t) minus sine of 3ln(t). So that is V1, and we multiply by cosine of 3ln(t). That is y1. And plus V2 y2. V2 is just 1 over 9 cosine of 3ln(t) times y2. y2 from the previous page is sine of 3ln(t). Right. Now, you can see that when we multiply this out, make another mistake, just minor one. When we have the 1 over 9, that is for the whole thing. So if we multiply it out, we have 1 over 9 here as well. Right. So we have 1 over 9 sine of 3ln(t), and then multiply this with 3 cosine of 3ln(t). We have a sine and cosine times 1 over 9, which will cancel with this because 1 with the minus and this one with the plus. So when we simplify those two, we will have the particular solution is just 1 over 9 ln and all that. Ln secant of 3 ln t plus tangent of 3 ln t, and the negative 1 over 9 sine 3 ln t, that cancel out. Once again, sorry about that, we should have the 1 over 9 outside. But that is only the particular solution. So the solution, the final solution is going to be so our final solution is the homogeneous solution plus particular solution. Homogeneous solution is cosine 3 ln t plus C2 sine 3 ln t, and then the particular solution, which is 1 over 9 ln of secant 3 ln t plus tangent of 3 ln t. And that's what we have for this problem. So the concept is similar to the equation with the homogeneous with constant coefficient. We find homogeneous solution, which is Cauchy-Euler equation. Our particular solution, we use Cramer's rule. It's the same way. It's extremely tedious on this problem, by the way. So let me zoom out one bit. Right. So that will be the first page. We're going to find similar to the Cramer's rule, and after that we find V1. Once again, this should be the bracket which I forgot, and then V1 and then V2. The particular solution is still in the form given by variation of parameters, and do that if on the calculation it's like this. Then finally we have particular solution plus the homogeneous solution, and we're going to have the solution we have, except we still forgot that this is, I forgot the cosine 3 ln t here. Yeah, sorry about that. Again, I forgot the y1 in this case, which is this. Yeah, even though the sine cosine cancel, we still have that multiplied with the ln, and so that's what we have for this problem.